Okay, so page 65. So this first bit is going to be basically exactly what we did. And we're going to build on that idea in the last unit. We're going to build on that to expand it to other functions. In fact, all functions. So we're not doing any tables of values because we don't need to do those. So we start with y is equal to x squared. Everybody knows that it's parabola, correct? Yeah. Okay, there's its graph. Y minus 3 is equal to x squared. First of all, does anybody ever write y minus 3 is equal to x squared? No, what do you write? Exactly, it's y equals. I don't want this y minus 3 junk, so rewrite this. So we go x squared plus 3. Okay, what does that plus 3 do to the graph? Look at that language. Translates it up 3 units. It moves every point 3 units up. So 1, 2, 3. 1, 2, 3. So there's your graph. Okay. And then, what do I do with this one? Move the 3 over. X squared minus 3. So it moves the graph down 3 units. Moves every single point 3 units down. So this point, 1, 2, 3. This point, 1, 2, 3. You could do every one of these points. 1, 2, 3. You don't have to. 1, 2, 3. So that's what we did last unit. Okay, so there's the graph of x squared minus 3. We good? May I flip the page, please? Top of the next page, 66. What does this mean? Okay, absolute value of x. What does that graph look like? So it's a V centered at the origin. All right. So in 2, or II, what does the plus 2 do? Exactly. It does the exact same thing. It moves the graph up 2 units. What does the minus 3 do? Down 3. Okay. So you're getting the idea that any number outside of the function is going to do what to the graph? Make it go up or down. That has a variable. Every book will give it a different letter. Okay. This book gives it k, but it doesn't matter. It's the position in the function. So f of x is whatever function we start with. This plus k moves the graph up and down. That's all it does. The fancy math way of saying it is, I'm going to rewrite this because I hate it when they put the k there. Y is equal to f of x plus k results in a vertical translation of k units. You don't have to say vertical translation. You can just say a VT, right? Or understand what that means. You can actually just say up, down. I don't care how many units. So if k is greater than 0, i.e. if k is positive, we go up. If k is negative, we go negative, we go down. All right. Can I flip it? All right. Oh, this is my shorthand for positive plus VE because I'm too lazy to write positive. Here we go. You're going to see it a lot in this course. That's my shorthand for positive, and this would be my negative. I could just write plus or minus, but... All right. Going once, going twice. Okay. Start with the parabola again. We are not doing any tables of values. We're beyond that. That's grade 9. What is this? X minus 3. What does that 3 do to the graph in this one? Moves it 3 right. How do you know if it's 3 to the right or 3 to the left? What makes the bracket 0? Okay. In this case, it's positive 3. So it moves every point 3 units to the right. And then the graph just... That's basically what you did in grade 11, right? You did all parabolas, moving them left, right, up, down. In grade 11, they called them P and Q. We're just going to change the letters. Doesn't matter. What does this plus 3 do? 3 units to the left. 1, 2, 3. Okay. Any questions about that so far? Do we remember what radical graphs look like? Square root graphs. Okay, so the basic square root looks like that. What does this 4 do? 4 units to the right. So instead of starting at 0, it now starts at 4. That's all we've done. And the 2? Boom. So this is called an H value by this book. Last year you would have called it P, all right, because it was in with the X. It doesn't matter the variable they assign to it or the letter they assign to it. It's location. If it's in with the X, it moves the graph left and right. So H moves graph left to right. So what's the mathematical term that we would say instead of saying left, right? Horizontal translation of H units. Okay, if H is greater than 0, in other words, it's positive, we go which way? We go right. If H is less than 0, we go left. Okay. So tell me what we did. F of x plus 2. We going left or right? We're going left, right? Even though it says plus 2, you ask yourself what makes the inside 0. Okay, so our H value here is negative 2. Okay? So we're going left. That's the only trick with the H's. It's what makes the inside of the bracket 0. We okay with that? All right. Okay. All right, tell me what we did. We start with this, f of x, some general function, don't care what it is. F of x minus 3. Now this is our general formula we're going to add to it over the next week. We're just talking about h and k. So is this 3 an h or a k? It's an h, right? Because it's in with the x value. What is the h value? Positive 3. If it's an h value, we go to the right. Well, in this case, to the right, because it's positive. So we'll write 3 if you want. You could say ht by 3. I don't really care what you say. All right? Horizontal translation by 3 instead of vertical. What about b? Is that an h or a k? It's a k value because it's outside. So we went up 4 units. Or vt up 4 or vt by 4. What's wrong with c? Yeah. So you have to move that 1 over by adding it. You don't add it to the 10. Those little bracket things protect it. Okay? So that's a k value, or an h value, sorry. So this becomes f of x plus 10 plus 1. So we've done 2 things. What's my h? So that means we went left. And my k is 1, so we went up. Is that okay? So now we're just adding, we're giving specific values and applying it to any function instead of just quadratics and absolute values like we did in the last chapter, or radicals. Okay, now we're going to move a point. All right, so they're telling us this is our original point. It's on the original graph. And so the question says, state the coordinates of the image of this point under the following transformations. That is basically just saying, whoops, where has the point moved? Where did it end up? What are its new coordinates? So y plus 8 is equal to f of x. What have we done? What sort of translation movement have we done? You went down 8 because I need to move this 8 over there. Which means that's my k value. Which means we went down. So if you go down, if you're moving a point down 8 units, are you affecting the x or the y value? The y value. And this is our original point. So there's our x and our y. So there's 2 ways to do this. One is the algebraic way. So the new point is just your original y value. I'll write the formula. Y plus whatever your k is. So in this case, it's going to be -3 plus -8, which is what? Minus 11. If we don't go left and right, does the x value move? Change, I guess I should say. No, right? So the new point has coordinates 2 and -11. All right? If you like a visual, if you prefer a visual, I'll do it down here. Our original point is 2, -3. 2, -3. There's our starting point. We move the graph 8 units down. So you just go 1, 2, 3, 4, 5, 6, 7, 8. That's where we end up at -11. So this green point has coordinates 2 and -11. That's all you're doing. If you prefer that. But I will warn you, when we get into more complex ones, the algebra is actually way faster. Okay. But if you like that, by all means do that. B, what have we done? Okay, so our H value is 7, our K value is 5, so that means we went right and up. The new point coordinates, this is sort of a formula, we're going to add to it later on, will be x plus h, because your h value affects your x, and y plus k. Or you could do the graph, mark it out, and do it, but I'm just going to do the algebra. So our original x coordinate is 2. The h value is 7. What's 2 plus 7? 9. Our original y value is -3. The k value is 5. -3 plus 5 is 2. So the new point is 9 and 2. Are we okay? Any questions so far? All right. Last couple questions before I give you some examples. So now they're going to tell us what to do. We got to write the equation. All right. Our general equation so far is this: x minus h plus k. You just got to fill in the h and the k. Okay. So we do a horizontal translation of 5 units left. Is that an h or a k value? H. And what is the value of h? -5, because we went left. So my h value is -5. If I don't say anything about going up or down, what is my k value? 0, exactly. Okay, so what's the equation?
Y equals f bracket open x plus 5 bracket closed, and that's it.
That's it. F of x plus 5. You just fill it in. All right, 3 units up, h or k? So it's just f of x plus 3, because our h value is 0. And the last one, m units right, p units down. Yeah, so h is m, and k is negative p, because we went down, right? So the equation is just f of x minus m minus p. Is that okay? We're okay with that? It's just giving a formula to what we've been doing, basically, and applying it to any function. Here's your questions. 1 to 4, but on 4, don't do C. And then 7 and 8, please. I'll pause this. We've done it with points. We've done it with just general equations or functions. Now we're going to do it with a graph. All right? They give us this weird looking graph. They don't tell us the actual function. They just say it's y is equal to, or f of x. That's what they're calling it. And we've done this, f of x minus 2. What does that do? Is that an h or a k? That's an h value of, which means we went to the right 2. So that means you move every single point 2 units to the right. So we start with this point, 1, 2. And mark the points as you go, and I connect them as I go, because some graphs it can get confusing. There's your graph. And you can see we moved it 2 units to the right. That's it. What about the next one? What's wrong with the way it's written? Yeah, move this thing over there. So I'm just going to go -2. There we go. Okay. What have we done? What's my H? -3, which means what? Left 3. And my K is? Which means we went down. So every point goes 3 units left and 2 units down. So move every point 3 units left, 2 units down. There's your graph. That's all you're doing. All right? They give you a graph, you just figure out your H and K and sketch the new graph. We okay with that?
Yeah.
6 and 8, please. So, up to this point, we've done H and K. All right? There's our formula. This formula will expand. There's other letters that we're going to add into it. But for right now, it's just H and K. H moves it horizontally, and K moves it vertically. Okay, and we've only applied it to sort of general functions, f of x. Now we're going to start to apply it to specific functions. Okay, so you just have to tell me what we did here. We're going from x to the power of 4 to x to the power of 4 plus 3. Is that an h or a k value? K value. Because an h value would be in the brackets with x, okay? So this is a k. K is equal to plus 3, which means we went up 3 units. All right, B. How's that? Are we happy now, people? Yeah, get the numbers right. Okay. What have we done? We went from this to this. What changed?
We went right 1 and down.
That's right. We just went right 1. The only thing that changed was this. Okay? So h is equal to 1. So it's right. What about C? H and K. What are H and K? Okay, what's K? What's this 2 represent? Okay, so that means we went up. Okay, and you know it's K because it's outside of sort of either brackets or absolute value or whatever. It's not tied up with the X. If it's tied up with the X, it is your H value. So what's my H value? Positive 6. What makes the inside 0? Okay, so H is 6, which means we went right. All right, what about D? What's the only thing that's changed? It's an H value because it's tied up with the X inside the radical. What is my H value? -1. So we went okay. Now you got to tell me the equation. I'll tell you in words what we did. I'll tell you the starting function, and you have to give me the equation. So it's a parabola. We went 3 units to the right. Is that an H or a K? What is the value of H? +3. Okay. What's the equation? Like that, right? It's not this. What would this be? That would be 3 up. If it's an h value, it's tied up with the x. Okay? So it's not that. All right. 10 to the x, vertical translation, 2 units up. Is that an h or a k? Where does it go? If this is our, you don't know, that's an exponential function. We study that in the next unit, actually. But where does the k value go? Does it go with the x? No. So we just go, we take the function and we move it 2 units up. So we just go, well, plus 2. That's it. You just tack it on to the end. If I had said 2 units left, what's your h value? -2 is your h. Okay. Where does it go? Yes, it goes with the x, even if the x is an exponent. So it would be y is equal to 10 to the x plus 2. Okay. Your h value is always with your x. Okay. All right. Root x. Yeah. Root x, after we go 4 units left and 3 units down, what's my h? -4 because we went left. What's my k? Okay. Which one goes with the x? So what is the equation? Is it -3 in the square root? Perfect. So it's x plus 4. That moves it left. And then to move it down, we just tack on a -3. Is that okay? All right. Now we're going to do it with graphs. On the next page. Last 4 questions. Here we go. So we're going from the thin or the light colored to this dark colored one. Okay, so we start here. It's an absolute value graph. Just figure out the vertex. How do I go from here to there? What have I done?
4 down.
2 right, 4 down. So if I go 2 right, my h value is what? 2. If I go 4 down, my k value is? So what's the equation if it's an absolute value? X minus 2, all in absolute value with a -4 on the outside. Okay, B. Now this is a really funky graph. We're going to deal with these later on. When you have variables in the denominator, you get weird things happening to the graph. Okay? Why do you get weird things happening to the graph? What are you not allowed to divide by? 0. That's why you can't put 0 in here, okay? So we're going from this, just pick half of it. Ignore that out. I'm going from this point to this point. What have I done? Up 2 over 1. So up 2, which is my k. I went right 1, or that's my h. H is equal to 1. Okay? Where does the 1 go? Okay, so how do I write that? 1 over x minus 1. Okay, you can put brackets. Now, if I want to go up 2 units, what do I do? Where does the plus 2 go? Yeah, it's not in the denominator. It's just like that. Okay? All right, last 2. I'm going from this one to this one. This one, they don't even give us the actual function. They just say f of x. They're being lazy. So what have I done? Down 4. So it's just y is equal to f of x minus 4. And even though we know this one is a parabola, negative x squared, they're just saying f of x. So how do I go from here to here?
3 right, 4 down.
3 right? 3 left, right? Correct, I mean? So h is negative 3, k is 4 up, or plus 4. So it would be y is equal to f of x plus 3 plus 4. Is that okay? Questions? So this is not these two, but these two up here. This shows like why this is important, because if I just gave you that graph now, you don't even need to know that. You know that this center has been moved 4 units down, 2 units right. So you can generate the equation. Having the equation with the graph allows you to do a whole bunch of stuff. If you've taken physics, you can then figure out points and extrapolate what the values are outside of your data points if you're collecting data. If you've taken calculus, you'll know that then you can do derivatives, you can do integration, you can do a whole bunch of stuff that tells you all this information that ties into physics and chemistry and engineering and all that kind of stuff. So that's why when you generate data, you'll create a graph in science, and then getting that function allows you to manipulate it more. Okay? One, 2, and 4, please.